Hello, my name is Heather Fontaine-Doyle, and this is a presentation of my semester project, a discussion of the compatibility of visual art and mathematics instruction. Teachers today are being asked to meet the needs of a diverse body of students. They are assessing content mastery based on a prescribed set of standards. Teachers know that one way to engage students at a variety of different levels is with projects. Now, what does it mean to have math and art together, and what does it look like to have art in a math class? You may have seen the golden ratio, which is in a lot of examples of art and architecture. You may have also seen the work of M.C. Escher. His tessellations and his metamorphosis style are very popular in math classes. You may also have seen the math of paper origami folding. Now, there's a problem, though. Despite popular opinion that arts instruction is very important to an education funding for arts programs has been steadily declining over the past few years. Now, despite these program cuts, teachers are finding ways to incorporate projects into their curriculum. And one type of project that they could integrate would be arts-based projects. I've been interested in this for many years. I worked with a teacher when I was student teaching and also as an assistant teacher. He was a master at bringing art into his classroom, and I got very interested about what's going on here. Why are kids engaged by this, and what benefit are these types of projects having for them? This all led me to my research question: how and to what extent are mathematics instruction and the creation of visual art complementary? The literature genres I chose to look at are neuroscience journals, education journals, books on the brain and learning, and more research kept coming up all the time, so there's still more reading to be done on this topic. I looked at a few different themes of research, particularly cognitive activation, long-term memory and retention, social and emotional implications, and some implications for the classroom. By cognitive activation, I looked at the areas in the brain that are activated during mathematical functioning and during art production. During math production, we know a lot about the activation of the brain during math functioning, but we don't know a lot about how the brain is actually acquiring that knowledge. Researchers have shown that the interparietal sulcus in the brain is particularly active when thinking about the idea of number. It's part of a vast network in the brain that includes functions of perception, motor, spatial, visual, and memory as well. And there's also some speculation that mathematics and language are linked. As you increase your memorization and calculation abilities, those are ever more linked to your language faculty. And it's a different part of the brain that's active when you are doing calculation than when you are doing estimation or considering the magnitude between two numbers. Now, in visual art production, they have shown that people who produce art have increased activity in their default mode network, which can be associated with psychological resilience. The areas of the brain active during art production are areas that include perception, motor, and spatial abilities. And some researchers, particularly Christopher Tyler, says that there may be a shared neural substrate which could increase transfer across learning areas. For long-term memory, art integration activities promote elaboration, rehearsal, generation, effort after meaning, emotional arousal, pictorial representation. These are all shown to increase long-term memory and retention. And it also promotes what David Sousa calls cognitive closure, which assigns meaning to content once you've learned it. These social emotional implications, art activities have been shown to activate reward circuitry in the brain. And Judy Willis says that we can remember this acronym RAD, which challenge and novelty will get information through the reticular activating system. A calm learning environment will get information through the amygdala, and enjoyment of art projects will help with the release of dopamine, which shows that retention is more likely when those activities are enjoyable and when students have a positive emotional response. In the classroom, art activities use inductive and deductive reasoning and algorithmic thought, and art often involves inspiration. in which the cortices are active in concert with the limbic system. Now, in middle schools, topics that lend themselves to art abound. Ratio and proportion, scaling, magnitude, linear relationships, exponential growth and decay, geometry, all of these things lend themselves naturally to art. In the analysis section, I talk a lot about my personal connection to this topic. I have seen students who have thrived in classrooms where art projects were incorporated. Students who thought of themselves as poor math students suddenly became more positive about their outlook of themselves as a student once they see that not all math is formulas and computation. There are art projects that involve absolutely no numbers at all. Euclidean compass constructions, as you see here, those are just using a straight edge and a compass. No ruler, no measurement. It's precise. You have to really attend to detail. It takes a lot of time and effort, but it doesn't involve any numbers, and that's a great leveler for a lot of students. Art projects involve inspiration, as I said before, and a positive emotional attachment can really engage students with the content being learned, and they'll get, they'll retain that content, and it will go into their long-term memory. Psychological resilience is improved with art projects. You have to persevere through a difficult art project, and as shown in some of the research, that can activate the default mode network. As we showed before, there's some possible cross-activation of neural networks. Things are taking place in areas of the brain that activate for motor functions, for visual and spatial functions as well, and long-term retention of content and transfer. In conclusion, there are several apparent benefits to integrating visual art production into the mathematics classroom. The limitations of this study: there needs to be some further research about specific application to mathematics. There's quite a bit of research out there that I discovered about art and its ability to enhance learning in general, and what it does for retention and what it does for emotional attachment to content. But I did not come across a lot of literature on mathematics and art specifically. Possible area for future study might be to look at a specific content area within math, and then at the end of a unit of study, possibly have students work through an art project and maybe a control group not work through an art project, and see where that lands them as far as their retention of the content down the line. These are the references that I've used in my project. I've referenced them here in the slide presentation as well. And thank you very much for listening.